Hello students, we learned about the second law of motion where we understood that we need an external unbalanced force for any object to change its state of rest or of motion. There we understood that the force can be represented as the rate of change of motion or momentum. So when we talk about momentum, what does momentum stand for? Momentum is necessarily just mass times velocity. So what is mass and what exactly is the velocity at which we are measuring, that will tell us more about it. An example that we are going to start off is a famous example. Let's say you would have seen a cricketer catching a cricket ball. Generally, the cricketer will not be catching it at that particular height. He sees the ball or he receives the ball. He's always going to take his hands in a downward direction. Why does he do so? Think about it. We'll see about that in this particular topic. So when we try to understand more about momentum, so that is what we define as a kind of a momentum experience. So you would have seen, most of you play cricket, most probably. So a cricketer is going to lower his hand when he catches a cricket ball. So for instance, let's assume that this is a cricket ball. So he has to lower his hand. So in this case, he needs to decrease the force with which the ball is coming, so that it doesn't hurt his hand. So therefore, what he does is that he increases the time by lowering his hand, and therefore the acceleration of the ball decreases, because acceleration is going to be the change in velocity with time. Because for the same velocity change, final velocity has to be 0. So for the same velocity change, if he increases the time, obviously the acceleration, the time taken increases, and therefore the acceleration decreases. So that results into a kind of a momentum experience or this is a kind of real life experience for any person. Similarly, if a judo champ needs to break a pile, so what he does is that he tries to do it at a very fast pace. So when he does it very fast pace, as that it increases the force, right, with which he can break. He cannot break it if he does it slowly. So if he does it slowly, in that case the acceleration is going to be less, and therefore the force acting is going to be less, even though he may be raising his hand or he may be bringing down his hand at the same speed. But since the rate of bringing that speed is different, so he needs to do it as fast as he can. So if he does it at a fast pace, obviously it is going to result into a higher amount of force. That is the reason he does it like this. Similarly, if you have a long jumper or a high jumper, in this case the athletes fall on a cushioned bed to increase the time of stop, because if he falls on a kind of a rough or a very hard bed, in that case he can break his bones or anything. So this results into the decrease of the rate of change of momentum, and therefore the force that is acting on that person when he falls down. So to put it precisely in a mathematical form, we can say that we know that force is actually is proportional to the change in momentum per unit time. So if I remove the proportionality sign, I put a proportionality constant as k. So we can say that F can be written as k into change in momentum per unit time, where k is nothing but a constant of proportionality. So if I take the limit delta t approaching 0, in that case the term delta p by delta t actually becomes, because this is just a limiting case, that it becomes something like dp by dt. Therefore the force can be written as k into dp by dt. So for a fixed mass, what you can say dp by dt is nothing but, that's my fault that this should have been d. So it should have been d by dt of mv, because mv is the momentum here. So mass can be taken out, so this will be given by dv by dt. dv by dt is nothing but the change in velocity with time, that is nothing but the acceleration produced. So we can simply say that the force is nothing but k into mass into acceleration, where k is just a constant. For simplicity, we can choose the value of k equals to 1. Therefore, this is the net expression of force that we get. Now let's try to analyze some examples. So we know that, let's say, the motion of a particle of mass m is going to be given by this. This we found in our kinematics expressions. So here, if I have to find out the force that is acting on the particle, so how do I do it? Since I know that y equals to ut plus half gt square, when the particle is moving under the force of gravity only. Therefore, if I differentiate this, so v can be given by dy by dt, which will give me nothing but u plus dt. U is nothing but the initial velocity, g is the acceleration due to gravity, and t is the time taken. For acceleration, I need to differentiate it again with respect to time, so that gives me dv by dt. So the acceleration in this case comes out to be equals to g. So the required force is nothing but m into a, which gives me mg. So that is the reason the force that is acting on the object is nothing but the force of gravity. So this equation describes the motion of a particle under acceleration due to gravity g, and y is the position coordinate. Similarly, let's say if you have a force of 10 Newton, which gives a mass m1 an acceleration of 5 meter per second square and a mass m2 an acceleration of 10 meter per second square. If both the masses are tied together, then find out the acceleration of the combined system. So what we'll do in this case, we can find out the mass of the first one and mass of the second one. So when you tie it up, obviously the total mass is going to be together. If you know that what is the net force action, the net force does not change. The net acceleration in this case can be written as F divided by m. So this m is nothing but the total masses 1 plus 2. Therefore, that comes out to be 10 Newton divided by 3, which comes out to be 3.3 meter per second square. So this is how we find out the Newton's second law of motion. Hopefully, it made sense. We'll discuss further on it, the problems on it, in our discussion classes. Thank you. So students, we learnt about momentum. So any object which is in motion will have some amount of momentum, because momentum is nothing but just the mass times its velocity. So that is what we define as the momentum. Now, when a force acts on an object, obviously that is going to result into a change in its momentum. That is going to be our next topic, that is impulse. So impulse is defined as the rate or as the change in momentum. So stay tuned to understand more about impulse.